welcome to this use case about claims processing. In this use case we're going to discuss an insurance company called Avalon. Their current challenges is to have a claim processing process that is under 1 week, but nowadays it's taking 8 to 14 work days to complete the case. So the management is asking how can we improve this, and would hiring someone, for instance, make sense to remove all the bottlenecks that they have in the process. The data has been extracted for about 6 months, which has about 4,000 plus claims, and the analyst is going to look at the data, what they can find to improve the process. So let's dive into it. The analyst will use the following approach. First, is going to read in the data into our system to visualize the process and see where the problems are currently. Then it's going to be enriched so the process makes more sense with the decisions that are made which cannot be extracted out of the data. Next, it's going to try to simulate the data to see what kind of behaviors would make an impact in the queues and the bottlenecks they have right now. Of course, once the simulation has been done, it's going to be a comparison between the actual data and the to-be state to see if the effective has a real result. Then, of course, the implementation takes place where the changes can be made in the real-life system, and then the circle continues endlessly to see what the effects will be after making the changes in the real-life system. This is what we call the continuous improvement loop. But let's now dive into the demo to see how we actually go about this. The data that has been extracted out of the claim management system is shown here. It has some basic information about, for instance, the event that took place, the time when it occurred, the resource attached, and for instance, the amount of the claim that was given. Of course, we have some other fields there, and you can add as many fields as you want to only help you to analyze it in a better way. But let's now load this up into our system to see what the effect will be if we visualize it into a process. For that, I create a new process, go to my data, and I'll simply select the file to process it in our system. In the background, it will automatically detect all the common activities that are in the system, the fields, the known case IDs, etc., to visualize the process end-to-end using our proprietary algorithms. I can now immediately see all the information that automatically attached to our process mining algorithms, like the case IDs, events, etc., but also the attributes it found into the system that I can use later on to filter my data on. Of course, the activities that are used to the process, to making all the activities visualize, and I can even deep dive into the data if I want to. If I now close my data attribute tab, I immediately see my end-to-end process that was visualized out of that data directly. I see the different type of arcs, some are thicker and some are thinner. The thicker ones give me information that has more cases flowing from the initial desk to the corporate verification. Also, I see only 602 cases going to the perform field inspection, and I can even visualize this, how the cases are processed by the data, by actually visualizing every activity. What I immediately see here is actually a bottleneck, because the cases here are going very slow. To visualize that in an even better way, I can change the metric on these arcs to represent the throughput times. And immediately I can see all the throughput times that take place between certain activities in the process. For instance, now the initial desk decision on more than 5,000 cases costs more than 36 days here to perform, which is of course the bottleneck in the system if you want to only close them within a week. So let's dive a little bit deeper in how I can visualize that. For instance, I can drag and drop a visualization bundle here with all the default graphs that I can use, for instance, to see how many cases there are, the average duration of an entire case, which is 6 days, the median durations, etc. Of course, all these graphs can be changed if I want to in any aspect that I want. So for instance, if I don't want to have the time attribute there or something else, or I don't want to have an auto bin, but I want to see everything in weeks, for instance, I can change the visualization. And of course, this is all interactive. So if I want to filter on a certain way, I can just simply select the filter and I can see in this time frame there are only 949 cases. Let's remove it again to capture the end-to-end process. Alright, now I have seen already what the bottlenecks are here, which is now causing 36 days, but I want to deep dive a little bit better to understand what kind of other issues there are in my process. For that I can do, of course, manual interaction, but I can also create an AI report, for instance on throughput times. If I drag this on my desktop, the AI will analyze my process, my data, but also the graphs that I put on my screen. Now that AI has finished processing all my data, including all the graphs, it gives me a summary of all the findings it has based on the data. It gives me an overview of the number of cases, claims, the throughput times, etc. It will also give me guidance on where can I set probably filters to see kind of behaviors. It gives me key insight, for instance that 20% of the cases are still open, but it also gives me information and recommendations, for instance the implementation of work in progress limits and the activity management engaging open cases. So all kind of things that I could do. So, but how do I know how the process would now behave if there are, for instance, seasonal changes with number of cases coming in, with stormy weather, for instance, or what will happen if I add or remove certain resources to my resource pool? Well, that is why we have our simulation engine. With our simulation engine here on the right hand side, we can simulate all kind of scenarios to the process, resources, queues, but also patterns and decisions that are being made by the process. All this data is automatically detected by our algorithms for the simulation engine, and I can start making changes to them. Now looking at the cases, there are an average of 32 cases coming in on a daily basis, which is about 4 cases per hour on a weekday. So what will happen if the season changes and it will go to 6 cases per hour in average on a weekday? What will happen then? Now I can just simply run the simulation, and the simulation engine will add another data set to my visualization so I can compare what will happen if I run the simulation. So now the simulation has been done and attached to the process, I can see that all the information is now doubled. One from the original one and one from the simulation one. I can see, for instance, here the number of cases has been gone up since we configured that in our simulation, but also now the throughput time has come up. So here there is no issue, but here is also not an issue, but the number of cases that these people can perform are way too slow. So it now goes down to 54 days instead of 36 days, only by adding a couple of cases more on a daily basis. So definitely there is an issue here. What I simply could do is change the resources. So the resources that are attached to this activity can then be found on the selected element and resources, which is the field accessor. So what I could do is upper the field accessor number of resources, see if this will actually affect. So let's say we add another resource, which will cost me a lot of money, but see if those problems will be resolved. I run the simulation on the same data set, so it will keep the same color here. So it will see what will happen to the 54 days now. So looking at the data set that has now been finished, I can actually see that it dropped a little bit to 42 days, but still way not enough. So how can I now make sure that I can make changes to the process which will not be cost effective by hundreds of users, but change the process in such a way? Well, for instance, what I see here is that the claim values above 5,000 are only always performed by this person. So what would happen if I make changes to that? Let's say I don't want to have the distribution higher than 5,000, but let's say 10,000. Of course, I need to do a better analysis of what the impact will be in that sense as well, but I can now already simulate without making real changes to the process what the effect will be if I make a decision above 5,000 to 10,000 here. Run the simulation again. So this impact is now enormous. Going back from 36 days on an easy week to 42 days on a busy week, actually with adding resources, and now only going to 16 hours with only 3 resources, but only making different decisions when claims need to be checked and when not. So this is a huge impact, and the overall impact is of course then very big as well. If I would now automatically shut off the other data sets and focus on the simulation, it now has an average duration of a completion of a case in 7 hours in total, which of course is huge for this organization. Thanks for watching.